Brad Folta with the Minnesota Geospatial and Geomatics Institute, here to share with you a great interview coming up with Dan Roman from the National Geodetic Survey. This is part one of two, as it goes over the course of 2 hours. However, I encourage you to watch the whole thing. It was super interesting. It was super fun to talk with Dan, and I hope you like it. Let us know in the comments. So, hi everyone. Brad, the executive director with the Minnesota Geospatial and Geomatics Institute. Today, I'm honored to have Dan Roman, the Chief Geodisist for the United States National Geodetic Survey, here with us to talk about the field and geodetics and what it is and what it means and what they do over there at the NGS. Dan, did you want to introduce yourself?
Well, thank you. I appreciate it. I'm glad to be here, Brad. I basically have been working pretty much at this job, progressing through it for about the past 23 years at NGS. And as far as background, I had about 30 years in the Navy, both active and reserve time. Retired from that, and I'll mention that I think in some of your background questions. I'll follow up with that about motivation for GNSS and GPS and all of that. But quite honestly, after I left the Navy on active duty, I joined up at Ohio State University, got my advanced degrees there, particularly focusing on the Earth's gravity field. I had a keen interest in particular in studying heights, vertical, in terms of where things are located. And basically that just kind of gravitated to the National Geodetic Survey.
Oh, very nice. Well, so you've mentioned it. How long would you say you've been in the geodetic industry? Did it start in the Navy, or was it after you got out of the Navy, or?
I would say my interest was peaked in the Navy. It was after I got out of the Navy. It's about 6 years of schooling and other things I was doing. After I left the Navy, finished in '99 and started working at NGS and have continued to work at the National Geodetic Survey over that entire period.
So off that, like what drew you to the field? Did somebody say, hey, by the way, there's geology, then there's geodetics, or was it something you fell into? Like
my bachelor's, even though I joined the Navy, yeah. My bachelor's was already in geology.
Oh, gotcha.
So it made more sense to go in the Army or maybe the Marines or something like that. But I was always interested in geology, always interested in the Navy. And looked at marine geology, but in the end, I found a general Bachelor of Science degree in geology serves you better because after that, you can specialize. And I was figuring that I would come back off of active duty at some point and go back for some type of specialty degree. While I was in the Navy, and this is what piqued the interest. I wouldn't classify it as, in the GNSS industry at that point. I was a ship's navigator. And so my job was putting the ship's position on in the middle of the ocean. So one of the things that piqued my interest is they said, well, you have to calculate the geoid height. I'm like, geoid height? I'm in the middle of the ocean. What do I need to know a geoid height for? Right. So I had no concept at all about a geoid model or anything like that then. I did get a signal down. It plotted a usually pretty decent position. It was the old transit system and all of that, but it's still pretty decent position, especially in the middle of the ocean. Right. Of course, when we got in near shore, piloting, whatever you need to do to make sure you pull in safely to port, but it was really nice. And you could sit there and you could still drop the GPS receiver locations onto the chart and you could see that it was hitting fairly well. So I was like, okay, so I'm not sure what to make of all this, but I was pretty sure that was going to be important. And that was, like I said, that was back in 91 or so, 1991. And I kind of said, not sure, but I think this is going to be something important. So I should probably go back and study something like this. And when I was flipping through, and back in those days, they didn't have everything electronic. I had a nice thick book with all the different advanced degrees. And flipped to Ohio State University and says something about geodetic science and surveying. And it was in big, bold letters and internationally famous program. I'm like, wow. So I looked it up and geodetic science is about the study of the surface of the earth, where things are located with respect to this reference system that might be defined for the earth.
I love it. Well,
so that's when I went.
Okay.
No, that was it. I was going to say, okay, then that seems like what I wanted to do. So after I left the Navy, then I went back over to Ohio State. My bachelor's was, as I said, was in geology, pretty straightforward, everything, sample a little bit of everything. But that was at the University of Southern California, and finished that up in '85. And then in '91, when I left the Navy, I came back to Ohio State. I was an Ohio resident, so it was cheaper.
Yeah, exactly.
That in-state tuition, that's important, especially
Right.
when you just left the Navy and now you're no longer employed. In-state tuition is an important thing.
Right.
But nonetheless, I attended there, got my 2 years. I got a master's degree in geodetic science and surveying, focusing mostly on physical geodesy. At that time, most of the programs are kind of stovepiped a little bit, and I was really interested in something like geokinematics, which I really didn't see a program in. So I took the geodesy courses, but simultaneously I was taking courses at the geological sciences classes that were focused on geokinematics, geophysics. And then when I finished up my master's degree, I actually transitioned over to the geological sciences department, where I focused on getting my PhD in potential fields geophysics, essentially. It was geological sciences, which is the cover that they provided for everything that everybody got.
Yeah.
But I took everything was gravity and magnetism, focused mostly on that particular area. Yeah. And going back to the geodetic science and surveying department to continue to take courses with them, because I was interested in a blend of both. What I kept seeing while I was in school was that geophysicists were taking all the results from all of these geodesists that were calculating gravity anomalies from satellite altimeters and doing all these different fancy things to them, and they were just taking them as gospel and saying, oh, this is gravity data, and we're just going to use this. And while I was in the geodetic science and surveying department, I learned enough about that to realize where the errors are in that process.
Yep.
And kind of, okay, so this is where error, systematic, and otherwise can creep into what's going on here.
Yep.
And then on the flip side, then in the geological sciences department, then I was able to take all that work that I had understood now and process it and know what the limitations were in the types of data I was producing, and therefore derive more consistent results out of it, knowing that I had to be a little bit more careful with how I was processing and interpreting the data. So that was 91, like I said, is when I started school. 93, I got the master's, and I admit to taking my time for getting the PhD. I finished up in 99. But
there's nothing wrong with that. It's just a better dedication to the study, right? Like it's just more.
Exactly. Well, I also recognize that college A was better the second time around. That I was over 21, and B, a little more significantly. Honestly, I was enjoying it, and I knew that sooner or later I was going to have to go out into the workforce and work.
Yeah.
And but I recognized at the time, I met my wife at OSU, and we've had a great family and all of that. But I remember the time that she and I spent at OSU, and it was wonderful. And we knew it at the time. And that's the key to it, is to know those types of things and appreciate them while they're happening, because sooner or later you have to go out and join the workforce and work. But I enjoy my work, so it's not so bad. Actually, quite nice.
Well, that leads right into the next question. How long have you been with the NGS?
Since I graduated in 1999. Literally, I mean, like the week after I graduated, I was working, and then within, I think a month after that, I had closed on the house, and 6 months after that, I married my wife, and then it was kind of a busy year.
And everything sounds like it fell into place. Like it was just a perfect transition right from education to the geodetic survey.
It was, and basically it was a continuation of my education. It usually is. I mean, the upshot is you learn a lot in school. There's no question. But in the end, every company, every organization, every agency has their own way of doing things. They have their own missions. And so what you do might be broadly applied, but you still have to tailor it to the mission of the agency that you're working for. But it was fairly easy for me to do. I stepped right into the role. I will say, and this comes into some of the questions I think that you wanted to ask later.
Yeah.
I was one of the last ones to come out of there. Dick Rapp was my master's advisor. Dr. Ralph von Fries was my my advisor for my PhD. But even as I came out, Drew Smith, actually, he was out a little bit ahead of me from the Geodesy program. But he was like Dr. Rapp's last student, PhD student. I think I was his last master's.
Oh, wow.
And he was gone, and then the whole program folded up after that and was absorbed into civil engineering and moved around into different components or in different locations. Essentially, though, that program fell by the wayside, and there was no new source of people coming in. I do remember, and this will get, as I said, to some of those questions you'll ask later, when I was enrolled there, I was looking around. And I was like thinking to myself, I must be doing this wrong. I'm the only one who's paying to go here. All the others that were there were
Right.
from NGA, from NGS. Well, it wasn't NGA then; it was DMA or NEMA or something like that back in those days. But the Air Force, everybody else was being paid to be there, but I was the only one paying to be there, and I was like going, obviously, I'm doing something wrong here.
You're in the sciences. You essentially are on a fellowship, but you're paying for the fellowship. There's, as I used to tell people on the geologic side or the chemistry side, you never pay to go to grad school, hopefully, unless you did really bad in undergrad and you had to justify your first year or two. Other than that, usually there's funds to pay for it.
Yeah, that was the master's programs where I was paying my way, because it was exactly that. It was first couple of years, but then I was on a research assistantship, a fellowship basically,
Yeah.
on the PhD track. But yeah, for the master's program, I just come out of the Navy, really hadn't applied for anything, thought that you were supposed to pay, and looked around and realized that I was the only one paying. And like, I could have gone to work for the government and then been sent back, but it's okay. I was quite happy with the path that I took. I did learn a lot, had the opportunity to go on for the PhD, learn a lot, enjoy life a bit while I was young enough and healthy enough to enjoy it all, and then go on to do some work.
Well, I was going to ask too, like, was it better? What did you pay for tuition back in those days in the 1999, or was it as scary as it is today?
Well, that was, yes, it was much more benign, and that's where that being an Ohio State resident
helped out
immensely. Kind of came into play. That's where the residency kind of came into play. Being a resident of the state of Ohio, I paid in-state tuition and therefore was much more discounted. But I still had to pay room and board. It helped, though, that, as I said, it kind of alluded to there, I had the active duty time, and now I was in the reserves. So I already had a part-time job.
Yep. Being
in the reserves. So it helped. Plus student loans and everything else that you have to take to kind of get by. But it wasn't that bad at all. Right. It really did not run up much of a bill at all, to be quite honest, for the master's portion. And then once I got into the PhD track, with the being a research assistant, certainly was covered. A couple of interns down at Exxon Exploration Company. That was educational too, but it paid very well. I mean, it was like $10,000 back in those days. That was $10,000 for a summer's worth of work. For a couple of summers, and that was really the kind of things that set me up very well for the rest of those years, in terms of being able to get through the years easily. But the master's path was definitely different, and had been out of school for 6 years, so it was a little bit of a learning curve. And I was supposed to understand linear algebra before I got to school. Well, that was a rude awakening.
Did you had to go back and take linear algebra and everything like that, or?
No, I had to figure it out on the fly.
Oh, figure it out. I've never.
That proved
it's never
challenging.
It
was good. I have decent math chops, but it set me back a bit, and I had it's back down on the power curve. I had to power up the power curve a little bit more, but that's okay. I got through it. I enjoyed it. I learned a lot about it, but I learned a lesson there that you pay very close attention. When they start talking about strongly recommended that you have, that means that you need it. They don't strongly recommend something unless you really need it.
Right.
It's always been true in life. So that's always good to know.
It's the one class that I never even fathomed to take on, because I was like, I'm a geologist first and foremost. Like, that's not a thing. we get back to the envelope speculations.
I know. I know. That was, and when I got over to geophysics, my advisor there, he was always like, well, it's geophysics. It's more of an art. Just tell me what you want the answer to be, and I'll figure out how to make it. I'm like, geez, is that how that works?
Exactly. That's geology to a degree. It's an art meets a science, and engineers will say one thing because numbers, and we'll say one thing because rocks. So
I know. And to be fair, geodesy is a much more exact science and engineering application, because it is the study of the Earth's gravity field, but from the Earth's gravity field from the surface up into space, where it behaves according to a set of rules.
Exactly.
Geophysics, on the other hand, is the Earth's gravity field maybe at the surface going into the masses. Exactly. So you have the answer. Now you have to figure out the question. Unfortunately, there's an infinite series of questions that can still give you the same answer.
Yep.
So there is a definite art form to it, and there's ways of constraining it. But nonetheless, there is a certain amount of art that is required there, but they still tie to the same thing. It's the Earth's gravity field. What
Yeah.
the sources are is what geophysics is concerned about, how it behaves and how you can use it to monitor what happens outside of the Earth's masses. That's where geodesy comes in, physical geodesy.
Exactly.
And so that's where my interest lay in basically the transition between the two. So that's where I kind of got into the interest in geokinematics, geodynamics, things like that.
That's awesome. No, and I think what's fun, especially for the people that are going to be watching this, is that it wasn't a chemist that brought you. Didn't start out chemistry, end up in geodesy. You started out with something, and this is what I always praise geology about. It opens up your mind to a whole other aspects, because geochemistry is different than geophysics,
Yes.
even though they play together, but they interpret and see the world in a different way, and that's okay because we need both, because that's the only way to get to those answers.
And that's why I made sure my bachelor's degree was broad. I took geochemistry, I took geophysics, I took the paleo, I took everything there was to take. It was a good broad sampling and field geology. That was probably the most fun, honestly, going out to draw maps in the fields. But all of that was a good sampling of what geology is about. And from that, then you can start to narrow your focus a little bit and pick something that was really of interest to you. And then that's when you go in for your master's and narrow it even more if you have a PhD.
Exactly.
And then I always tell people, return on investment, a bachelor's is worth it, hands down. It's really, if you have the chops for it, it's not going to be too arduous necessarily.
Yep.
Master's, there's still a pretty good return on investment. It's still worth the time, the couple of years generally, and the amount of energy and everything you have to put into it. A PhD, okay, it starts to become very much more vertical. Yep. You'd better want a PhD more than just because you think it's going to give you a pay bump. I know a lot of people that got their master's, went into industry, got a real job, and started making money. And by the time the person finished his PhD and came out, the person who had just the master's was already making more money, had already had greater experiences, and was already moving on. If you want the PhD, it's because you want the PhD, not that you think it's something you have to get or anything else. It has to be an internal motivation.
It's a passion. It's not it's not a career
fodder like
or add to. No, yeah.
Oh, that's definitely right.
Well, so I think this next question is a fun one, because what was more valuable in your career, your education or your experience? And I think for you, it sounds like both, right? Like the
education set it up, but as I alluded to before, the experience is really where you start to bring it all together, and you start to see, okay, I've done this, I've done that. Okay, the education helped, because it really did help me understand and be able to interpret things, to understand how the geopotential fields fluctuate and how they change and what's going on, mass changes, and visualize that.
Right.
Then you still have to apply it and what's it mean, and that's where it really starts to get more fun. So the experiences kind of came in after the education. The education was fun just because I was in college. I didn't have to be working necessarily, other than schoolwork and everything. And I realized it was hard work at times, definitely.
Yeah.
But the pace of life was different than it is once you go out and you seek employment and you're working out in the world. Right. You have to make your way through it. Yep. Then there's no more, I'll take it mañana or any of that kind of stuff. No, it has to happen now.
Yep. Well, that actually leads to it. So how does, working for the agency differ from other areas that you worked in? You mentioned Exxon as an intern. You mentioned.
I would say it was definitely, keep in mind that I had continued to be in the reserves, and I was in a lot of classified positions doing work for the government, as in the military and the Navy for various commands throughout the world.
Yep.
And in all honesty, and I totally understand why, I found that the level of security and sensitivity about information was greater at Exxon Exploration Company than in a lot of the government agencies I've worked for when it comes to classified data. Now, don't get me wrong, I'm not saying that people are slipshod in the government when it comes to classified information, not at all. Yep. But the level of sensitivity was greater there, but it was probably because I was being more directly exposed to it. I know there are components within the United States government that have that same level of sensitivity and concern, and they focus on it. But it was much more my personal experience seeing it at Exxon, and all the other exposure I had within the rest of the government was nowhere near that level, because it was nowhere near that sensitive of information.
Yeah.
But within Exxon, it was clear that this is their life's blood, that understanding where the oil was, how much oil was there, and keeping it a secret from anybody else and not trying to divulge it. That's their life's blood. If they lose that, they're going to be out of business. So I get that. That is literally survival for them. And so
Yeah.
that's why the intensity of working for them was very great. And I was like, I was of two minds. The other parts that kind of decided it for me was Exxon Exploration Company, at least at that point. My choices were Houston, which I did my 2 internships in during the summer, hot and humid. And New Orleans, hot, humid, and swampy. And so I will admit that I'm not a fan of the heat, so that kind of turned me off on it. And in quite honesty, at that point, I already had offers to go on to a PhD program and then also to go on to work at National Geodetic Survey. So that's the path I opted for.
It pushed you that way. And that's, and I always tell people, and for the viewers of this, the biggest thing that most people don't realize about oil companies is they make their own coordinate systems, because as Dan was mentioning, if you know where my oil is, now I lose the lifeblood of why I exist in the first place. So anytime you see any of their information, or if anything gets shared publicly, it makes no sense to the rest of us, because they define the world how they need to define it to protect their industry, or their commodity. And so it's interesting when you start to look through those lists, or you get the massive list of coordinate systems that exist out in the world, or geodetic models or gravity models, what have you. It's all different, and anyone can make their own. You could make your own today. Dan could have his, Brad could have his. And
as long as it's internally consistent, you don't care.
Exactly. And the hard part is translating all that together. And so that's where it becomes fun. For people like me, I don't know, but
that's pretty much what's one of the concerns that we had. So we started flying gravity missions. And think about it, we're flying an airborne gravity mission over the entire United States, and we're going to collect gravity field information that can detect where all the masses are inside the Earth.
Yep.
I did spend a couple of trips going down to the SEG conference and laying out in exquisite detail what we were doing and what we were not doing. That we were flying at 20 kilometers elevation to 20,000 to 35,000 feet.
Yep.
Trying to collect information for the long wavelength gravity signals of the Earth, because the geoid follows the long wavelength of the gravity field, not the high frequency. That we were not going to be flying low enough to find out where all the little faults and the traps are for all the oil. Yep. That we're not going to be publishing that we were not going to be in any way, shape, or form impinging on that.
Right.
Quite the opposite, though. The one thing I did provide them, I said that what we would be providing is the long wavelengths, so that you could take all these independent surveys that you've conducted, and you should be able to meld them together using our reference field that's publicly available. You can internally take all your information and make it all meld together. Because one of the other problems that they encounter invariably with their surveys, particularly the terrestrial surveys, but even the airborne, is they're not as concerned about the absolute as they are the relative. They only care about where's that high frequency jitter that indicates where the buried reef might be, where the oil trap might occur.
Yep.
In terms of a tilt or a bias, they're not as concerned about that.
Exactly.
But when they do a survey and it kind of overlaps at the edges, and they don't have the control in place necessarily to meld it all, then that becomes a little bit of a problem. But if you have a long wavelength field, then you can normalize all of them and you can meld them together, so that you don't have to go out and collect that same area where the overlap occurred with yet a third survey. Because now you can meld them together, you can get that long wavelengths to pull all that together, and then you can try and extract the information you need out of there without necessarily having to fly a survey again.
Right.
Now all of a sudden, okay, that's more useful. Now they're like, okay, now what you're doing is useful to us. And then so we really didn't get any pushback from the industry to congressmen, senators who might have been concerned about us, collecting sensitive information and providing it to the public for free and to their competitors or anything like that. We were very careful to document that and be very forthright about what we were doing, that we're targeting the long wavelengths.
Exactly.
Because that's about vertical control, that's about floodplain control, that's about pulling all that information together.
Right.
And making sure that we have consistency from not only from one ocean to the other, but also everything in between.
Exactly. And that's, I think that's the fun also of this career field, is that it's you get to see behind a lot of curtains, and you get a lot of extra worries about things that no one else thinks about during the day. Like, oh, we flew aerial imagery over the whole United States. We should be able to publish that. And it's like, Not necessarily. There are things that we
Yeah.
don't want published. So
Well, and even the airborne gravity collection missions over certain U.S. Air Force facilities were difficult.
exactly.
Took
Yeah,
a lot of
go fly around.
coordination. Well, and some of it is, they're always doing missions, sorties, and training and everything. And you might find a time, but even then, they're still sensitive to people flying over certain facilities, and so
Yep.
you have to do it. We have a relationship between the National Geodetic Survey and the National Geospatial Intelligence Agency, and we went to them and said, "Can you please assist us with this?"
Yep.
And they went over and they talked to the Air Force group, and it would basically got permission to fly, do what we needed to do, and be done with it, and collect all of the data in that area so that we can meld it across the entire country seamlessly.
Yep.
But yes, there are sensitive areas, and yeah, there are things you're like, who knew? Who knew it would be this hard? But you find when you find a problem, you find a workaround, and you solve it.
Exactly. Well,
there will be more.
And I think that's the fun part too. For the other viewers, the thing about China, right? None of the imagery is exactly what it is today, because China causes a delay as part of their imagery for Google. So when you look at it, or you're looking at things in updated streets, to get it outside of our government, but when you're looking at their updated streets on an international level, or even zooming in on their stuff, it's not the imagery that is current. It is either predated, or it is a image made in the replica of what they want you to see, kind of a thing. Kind of giving that, well, as I told the customer one time, they called me up, and what had happened is that the state had defined the imagery that they had collected that year in a different coordinate system than what was being used. It was, instead of WGS 84 web Mercator, they did it in state plane. Well, they didn't translate it properly, so everything appeared to be about 6 feet off. And client calls up, my data's wrong. Well, no, it's not your data. It could be the imagery source. And that kind of confounded their head. How can the imagery be wrong? It's an exact picture of what we see. I was like, not necessarily. And if the coordinate system's off by 6 feet, that totally explains why everything's off. So
I know it's imagery it's ambiguous. It's not fixed in space. You have to have something to geo-rectify it, to orient it, to scale it, to fit it to a reference system. And that's what ground control is for. But you're right, if there's something going on, I can't speak to China or anything like that, but I can speak in a general sense that yes, we do collect a lot of imagery within the National Geodetic Survey, and yes, you need control. Yep. And on the aircraft, on the ground, you need to have things to pull all that together so that you have confidence in what you're projecting on the ground and the coordinates of the imagery, so that you know exactly where things are located. Because the other thing we're doing is, it's not just, here's the image. We just had a look at that today. We looked at, here's the Cape Hatteras area. Here's where it was before all the storms. Here it is after the storms. Exactly. And you have to make sure that all sews up, so that when you do fades like that, when you go back and forth, that those are in sync. You can't have them shifted or anything. They have to be in sync, and that means they have to be completely in a consistent framework.
Exactly.
You can't. So that's why having all that information is necessary as a part of the survey control that you have to set up. Again, our job is to do the geodetic control. Our job is to make sure that all the infrastructure is in place, so that people who want to collect imagery, if they want to collect LiDAR, if they want to do a ground survey, if they want to do ground LiDAR, if they want to do anything, that they have a consistent framework to pull all that together, so that you can stack all the layers together and compare them.
Right.
Otherwise, everybody's got their own independent reference system. And again, this is kind of what we're actually going back to an earlier. Well, it is, because right now you've got car companies developing their own autonomous information about where their roads are. Like, well, we've got all these receivers and we have all our cars and they're downloading information. So Ferrari's got their own, Ford's got their own. Is the Ford and the Ferrari in the same lane? Are they overlapped? What's the consistency between their frameworks? And if they're both going down the road in autonomous vehicles, are they going to run into each other? This is why they're supposed to be a national standard about where reference systems is. All of them should be stapling to the consistent framework, so that if somebody's going down the road, that they're doing it in a consistent framework, so that they're not going to be bumping into everybody. But I was okay according to what Ferrari said or Ford said. Well, that's nice, but in an absolute sense, you were over the line and you ran into somebody.
Exactly.
And
go ahead.
I know. So we can't have that. We have to have consistency. That's what standards are for. It's safety of life and property, and that's why we have them. And it's not frivolous. There's a reason that we've been doing this for honestly about 200 years, actually a little more now. 1807,
Yeah.
Survey of the Coast.
Yeah.
Thomas Jefferson founded it. We've evolved over the years, and we used to use chains and rods and theodolites, and now we use GNSS receivers. But all of that still ties to the same thing. Those are the means to access, but what we're accessing is still the same. It's the National Spatial Reference System, and we may realize and understand it better, but we're still trying to tell you where you are for positioning and measurement of where things are located, so that you can compare things to everybody else's stuff to make sure that you have that consistency, and you can extract even more information out of it.
Well, it's setting up essentially the kilogram for the country, right? Like you're setting the standard, which everyone defines their kilogram, versus what they used to do back in, like, middle age Europe. Yeah, exactly, right? Like where things change based on where you are. And so one thing weighs this much, one thing weighs that much, and there's no standard.
That's right. At the SI, I mean, for the longest time, the weight, the standard was actually maintained, but they now it's all digital and it's all based on atomic things.
Exactly.
But for a long time there was an actual physical weight that was that they pods and measures. I mean, yep. Measurements and weights and everything else were defined by specific things that were the standard, and you had to calibrate it against. I think 100 years ago or so ago, we had to take our rods and actually go and compare them against the standard rods for comparisons. Because again, when we were using rods, and we still use them for leveling purposes, of course, but if one rod's a little shorter than the other and all the marks are a little closer and all you're doing is shooting the same rod and it's off systematically, then your level survey is off systematically.
Exactly.
So that's why you have to have everything standardized.
Right.
Now it's GNSS receivers, and we standardize. We test the receivers, we test the antennas, we see how they orient and how they process signals from satellites coming in at different look angles, and we basically say, here's the characteristics, and we're basically able to remove that and say, with this level of precision and accuracy, here's where you should be located. Exactly. So we help to refine all of those, but those are all standards. We tell you how to do it, how to collect it, how long, what you need to do. But if you do all of those things, then you should obtain the result that you desire for, be it some type of a contract that you have, if you've got to go out and make a series of measurements, be it a property boundary survey or any number of other things, an engineering survey, or if you're just monitoring the deformation of a dam.
Yeah.
Looking for the ground to slowly deform over time, you need to be if you're doing repeat observations, you better be in a consistent framework to detect those small little changes and realize that there might be a big problem coming.
Right.
Again, all of those things.
So what you're saying is that we can't just off the hip shoot it every year and be like, oh yeah, this looks right. No, I'm deceiving. No, and that's the thing. That's one thing we're definitely stressing on our side here is that if at minimum be consistent in how you measure, be consistent in how you go about things, because as you were saying with that standardized error, you can now attribute that, and when you attribute that, you can adjust for it, versus if you do it inconsistently every time and therefore not repeatable, you have no way of knowing what's going on, and you just made bad data, as it were.
Well, your first clue may be when you like we did with NAV 88, when you get to the ocean, you go, why am I thigh deep in water? Oops. It's a little late for oops at that point, but
right.
Again, and I'm not at all belittling NAV 88.
Oh no.
Again, it was rolled out in 1991. That was 30 plus years ago. Yep. So for that time and all the effort that went into it and what they collected, it was wonderful. Yep. But it's no longer suitable for what the level of requirements that are out there now that people tell us. They want centimeter to millimeter like a positioning.
Yep.
In the vertical and somewhat in the horizontal. And in that case, then we need something that's going to be replacing it that they can meet those requirements. Well, so again, that's what we're aiming for.
It's like the theodolite in the early transits of the old days. Like when Delorme was running around France, 1 second was equivalent to about 46 feet, and that made you an amazing geodetic surveyor. And now 1 second is equivalent to what, 1 foot at 40 miles, calculating in the curvature. And it's like that's how far we've come. Again, no one knows about it, but it is one of those things, like to see somebody like Delorme's colleague who was off because of machine wear and tear, right? And he was off, and it was giving him 3 seconds of error when he was trying to be a 1 second geodesist. And it's like, it wasn't you, it was your machine, but we had no concept that things deform over time with, reference to a machine. So
And that's why you have to calibrate them all the time. We have calibration lines. We have all sorts of things, and it's exactly that. There is an ISO committee, 172 group, working group 6, that is focused on geodetic instrumentation and standards required to maintain them.
Yeah,
and that's our training branch takes care of that. It's basically, I mean, they do all the testing, training, and evaluation of things in terms of teaching people, but also checking the equipment and maintaining the equipment, developing the standards on how to use the equipment. But they're the responsible group that goes to the ISO TC 172 group, and they coordinate. They make sure that what we're doing in the U.S. with regard to instrumentation and how to maintain the instrumentation is consistent with the international standards. I'm with ISO TC 211. I deal with all the GIS applications. I make sure all of our datums, reference frames, and all that are loaded into a format in the ISO Geodetic Registry where anybody can download them. The GIS can say, a programmer can say, I want this particular number, which is related to WGS 84, and I want to transform it into NED 83. And here are all the necessary transformations and everything I need to download. So all I need to do is program in, pull this, pull that, give me my transformation, and I'm done. And that's what they want. And that's what a GIS programmer wants to do. They don't want to have to understand all the geodesy behind it. They want to be able to get entering argument, exiting argument. What do I need for my parameters? Give me the transformation. And that's what we try to provide that. We try to do all the hard, heavy lifting behind the scenes so that users find it a lot easier than when they go to utilize the programs.
Exactly. Well, and so great lead into the next one. But what parts of your job do you find most challenging?
I would say outreach and communication.
Go ahead.
I know. No, I would say outreach and communication, in all honesty. The difficulty is not passion on our side. It is, I hate to say it, but you probably experienced it, eyes glazing over, because it's like, oh God, not more math. I know when I get in there, I mean, it's like, it's all math, it's all physics of the earth and the geometry and all these signals coming in from space and massive equations to try and reduce it all down. In the end, it's about positioning and measurement and facilitating things. But it's all revolves around math. And a lot of people, because they can't understand it, is like, in some respects it's good because it's like, well, we don't know what they do, so we'll leave them be. In some respects it's bad because when we start sticking our hand up, say, hey, we need more money to do this thing better because here will be the benefits. And they're like, well, we still don't know what you do, so we're not going to give you any more money.
Exactly. It's a double edged.
So a lot of it then is my outreach and communication, is having to go to the Federal Geographic Data Committee and talk to them and talk to the other government agencies and say, you're supposed to be using the National Spatial Reference System. Geospatial Data Act says all the U.S. government geospatial data are supposed to be findable, accessible, interoperable, and reusable. Interoperable means that they're all in a consistent framework. You've got three options when you want to make things interoperable. Either you provide all the transformations, which is what we do with the ISO Geodetic Registry, to go from one system to the other, but you have to do that for every single data set. That gets cumbersome. The second option is the route that NGA is taking, which is to say, well, we're in charge of all the geospatial data for the Department of Defense, so we're going to take it all and put it in our database. Well, that's a big database.
It is. It's massive.
And that's not our mission on the civilian side. So we're not going to be able to do that. The third option then is to have a consistent reference frame, the National Spatial Reference System, that everybody uses, so that when you collect your data in that same system and I collect my data in that same system, we can compare them easily together. We don't have to organize them in a common database. We don't have to put them in one space or another. We can immediately compare them because they're already interoperable, and that's the key to it. They can be compared, and you can stack them, and you can extract all that information out. You can do things like look at the bridge and the overpass and from the satellite and the LiDAR and the water surface and do all of that because they're all in a consistent framework, and you can stack them and you can subtract them and you can do whatever you need to do.
And
that's our job then, is to go out and toot that horn and try and get people to sign on and say, okay, we're going to start to collect our data in this reference system, that we're going to be consistent about it. The hard part is that WGS 84, the DoD system's out there and it's easy to use. DoD signals coming down to, the Air Force programs the satellites send their signals to the ground, and the receivers pick them up. So if you just take the pseudo-range, the broadcast signals, you get pretty good positions. And again, that's what we kind of opened with in some of the earlier discussions.
Yeah.
It's okay to use that if you're operating, say, in space. And again, in the middle of the air or in the middle of the ocean is effectively in space.
Yep.
Nothing really to really bump into. But as soon as you come up against the build infrastructure, against shoals, against anything where you now have to have a higher degree of precision and accuracy, now you have to have an understanding of the terrestrial reference system. Where's the ground depth? Because the Earth's surface is always deforming, it's always moving.
Right.
So where are you with respect to that becomes now more of a concern. And so then how do you tie into that and be consistent in all of that? And trying to communicate that to, like the ship drivers are out there. I don't need to know about that. You do, because you say you want to be able to pull in seamlessly, cross over the 40-meter fathom curve there,
Yep.
or 40-meter depth curve, and pull in, not hit any of the shoals, pull under the bridge, and pull pier side on time. And you want to be able to do that with confidence that the ship's keel and the depth under it and all that information, you understand it and you're not in any jeopardy.
Yep.
The thing that always amazes me is that I was told some time ago the second busiest port on the Mississippi River, after New Orleans, is Memphis. That's why FedEx is there.
Yep.
All those ships go all the way halfway up the Mississippi River to Memphis to pull in and offload their cargo.
Yep.
Well, that's a lot of bridges you're passing under. Granted, they're pretty high, but some of them may or may not be. And there's still a lot of dynamics going on in terms of what's happening in the water, and it has to be monitored.
Exactly.
And so, yes, you have to have a really high degree of confidence in where you are in that river and the whole river system and all those different sections of the river on different datums to sew all that together to have high degree of confidence you're pulling in safely pier side. That's where the precision and accuracy come in, and making sure that you can do that seamlessly and not just coming in up the river or something like that, but whether you're passing through the Panama Canal, coming through the Caribbean, and then pulling into port someplace in the U.S., it's good to be in the same framework all the way through the entire system. So that's where our job is also to make sure that the National Spatial Reference System ties into the International Terrestrial Reference System. Exactly. So that when you're going across the border into Canada and your autonomous vehicle, you can flow freely across the border.
Yep.
Or if it's shipping or if it's aircraft, everything's consistent. And that's what we're talking about. That's the interoperability part of it. Making sure that our system that we're using in the US is interoperable with what everybody else is using, then everybody will be fine. And that is our task then, is to convince all the government agencies that they have to do that. Yep. Keeping in mind, and we've talked about it briefly at another time, that our remit is to talk to other government agencies. The US government is supposed to use this. But if you're doing business in front of FEMA, maybe to make a fermet for them, FEMA is supposed to tell you to use the National Spatial Reference System. So it ends up being everybody else ends up using it, again, for consistency's sake.
Indirectly kind of a thing. Yep.
It's an indirect kind of thing.
Yeah.
But again, if we're providing the precision and the accuracy of the data, not necessarily the ground above it. Again, if somebody's flying LiDAR, you want to be able to position that aircraft, and then you want to be able to take all that geometric information, because the aircraft's GNSS and all of that is going to provide you coordinates in a geometric frame.
Yep.
But you want to convert that to the geopotential frame. You want to know where water's going to flow. And it doesn't flow according to geometric coordinates. It flows for geopotential coordinates. That's the Earth's gravity field. So you need to have that transformation that says, here you're in the right geometric frame, and now here's your transformation to the geopotential, so you can figure out floodplains. You can do coastal and emergency management. You can do it along the rivers in the interior of the country. Yeah. You can do any number of commercial engineering, scientific applications, and all of them are consistent, and you can freely compare all the data with your peers who are collecting data maybe at the same time or maybe earlier, or they come in after you. But all of that data can be compared to one another, which is a critical aspect of trying to monitor this changing Earth that we live on.
Right. Well, yeah.
But all of that is hard to communicate. Exactly. That is, I sit there, I talk to you, and hopefully some of your reviewers are be able to follow that, and you can understand the passion and why it's important. So, you ask what's difficult. I also think that it's also important to me, because when I can get that across, then people understand it. Then they kind of go, oh yeah, this is important, and they see the need for it.
Oh, no, I was going to say that. Yeah, I think right there we heard the passion and the enjoyment out of it too, because it's not. I was a huge fan of West Wing at one point, and then LB Duncan, one of the older guys on the show, was asked, with diplomacy, how do you boil it down? What words can you take out of the thing to make it still mean the same thing? And much like what we're seeing with science and social media and everything today, everyone's asking, how do we boil down these topics? And as LB says, to the people on the show. He goes, no, the issue isn't finding what words we can say, it's finding all the words we can use to help express this, because it's not this simple. It's not, you can't just make it into a thing. You have to engage all of it, and you have to talk about all of it, because if you don't, you're going to miss a whole hell of a lot of it, kind of a thing.
I know, and it is. This is just different facets, and you want to touch them all, but again, it becomes too much. So you have to find the balance. You have to try and lay out enough to get across the importance of it, because you have to be conscious of people's time too. Yeah. I mean, particularly the higher level, the decision makers, they don't have the time to sit through a long litany of, oh, this is why you need to pay attention. They don't have that passion. They have a different passion.
Exactly.
But it's important, and you have to convey that to them in a short enough period of time that they get it. They go, okay, that is important, and I'll have some of my staff come over, or we'll do something, or if you could distill it down even more. But the thing is that's that hard part, that outreach and communication, how to drive that home and get it across to the decision makers,
right?
Not just in the government who might fund the work, but outside the government, especially, to everybody use the same system to make sure that we're all doing things in a consistent manner. That's sometimes difficult too. Sometimes it's easier because out on the outside, a lot of groups are like, yeah, we need somebody to do that for us. And it's great, you're in the government and you can do that. But then I got to get that worked into our mission, and it's got to be a part of the NOAA mission, and NOAA's got to go, yeah, that is a critical aspect of our mission. And then so does the Department of Commerce, and so does the whole of the government. And that's where that, like I said, it's the hard part, the outreach and communication, but it's also the most rewarding part when it is accomplished correctly.
Exactly. Well, because it creates that standard, and everyone knows that it is important, and it becomes, well, it's a mission, as you were saying, with getting it added to the mission statement. It's something that becomes the defining standard for everything. And when it's done poorly or done, well, yeah, that's why I look at it.
There's no passion.
If there's no passion,
then if people like whatever, then you're just a wonk who's doing his job, and then you don't have the chance to try and influence things. And we're kind of at a critical stage right now. We are talking about all these autonomous vehicles and all this automation of everything, and tying into the infrastructure, defining where critical infrastructure is located. The key here to get across, if I had to be succinct, would be that the Geodesy is providing the infrastructure for the infrastructure, that the geodetic control is how you define where things are located, so that when you do positioning and measurement for any other type of field, they're all using the same base layer so that they're all consistent. As I say, the infrastructure of the infrastructure.
Well, that's so this is awesome, because obviously you read through all the questions when I sent them to you, because you know exactly where this is all going. But yeah, so
they're on the left side of my screen right now.
Oh, gotcha. So you're just taking along as I skip over some, because it's like, oh, we answered that wholeheartedly. What is the difference between geospatial and geodetics then? And I mean geospatial, not like the whole litany of things, but more the geographic information systems or visualization side of things.
So geospatial is pretty much any component that has a geographic coordinate tied to it.
Exactly.
That's why it's the Federal Geospatial Data Committee. So they talk to everything from census. That could just be a street address. Is that a geodetic coordinate? Not really. But is it a geospatial coordinate? Yeah. If you go down the road and you stop at this street number, you have arrived at a location. It defines a location. Stream gauge data with the USGS. A lot of times it's measured along the streams. Yep. Where exactly that is in terms of latitude, longitude, and vertical control. But it's its own system of coordinates, and it's internally consistent. So those are all geospatial coordinates, and they're in terms of how you might describe where things are located.
Yep.
But geodetic control is really getting at the mapping. Geodesy is the mapping of the surface of the Earth. So it's knowing where things are located and defining a reference system that is consistent within that framework.
Right.
To say at XYZ, you're at this location. And that is really the heart of it. And is you said to say, the Geodesy provides you the control. Where's the datum? Where's the reference system? How are you oriented? Where's zero? If I say I'm this high, well, this high above what? The table, the floor, the center of the Earth?
Exactly.
Be specific. What's your data? What are you measuring from?
Right.
And that is what Geodesy then provides you as the basis. It says, here's your control. Here's your reference system. Here's its orientation. Here's where you are located within it. Here's where this other objects are located within it. Then it enables you to navigate. Navigation is proceeding between those fixed points of this infrastructure, knowing where these things are located, knowing where you are, you're able to move from A to B. That's navigation. Positioning is knowing where the things are. But all of that is oriented in some type of a reference system. And that's what the geodesy is providing. The geodesy, or the geodetic control, is where things are located, the framework for the positioning and the measurement of things on the Earth or with respect to the Earth. Anything then geospatial or geographic really has a broader context. It usually implies some geodetic coordinates or tied to something, but it usually has some other construct. It's at this location there's a city or a road or a house or a measurement was made. More often than times than not, my colleagues within NOAA, they go out, they drop an expendable bathyothermograph, an XPT, they put it over the side and they measure the temperature of the water column, salinity, pressure, whatever they need, because they're trying to use that to help build up what the water column looks like.
Yep.
But if they drop that XPT over the side of the ship and they don't know where they are, big deal. How do you tie that to anything else?
Right.
What you need then is to know where the ship was located, latitude and longitude at the very least. So when they drop that XPT over the side, they have a sense for where they started, the depth of the water column, so they can describe at that location the behavior and physical characteristics of the water column at that location. And they can do it at a series of locations, and from that build a model that describes the ocean in that particular area.
Exactly.
And it's the same with sonar or side scan sonars or something. If you're out there and you're navigating, and this kind of gets back to the old days of why we were involved with it.
Yeah.
You do a sonar, but you need to position the ship to know it's getting signals bounced off the bottom. That's great. Again, that's relative to the ship. But where's the ship? You have to fix the ship's position in an absolute sense so that you can say the signals that we're getting back are bouncing off the bottom, and the bottom is located at this location, at this latitude, longitude, and depth.
Yep.
Then you can describe and sew all of that together and describe a model that puts it all together. And I alluded to that. I mean, in 1807, when they had the Survey of the Coast established, the first thing that had to go in was geodetic control.
Exactly.
It's great. You got a ship out there doing soundings, but where's the ship? You have to put in shore control so that they can do coastal piloting to fix their position. Say, I'm here on the chart, and I just dropped the sounding over the side, and it's 20 fathoms. I'm going to mark a 20 on the chart at this location. But that location is determined from geodetic control on land. Nowadays, we're using GNSS receivers, and we have control stations, or cores or NOAA cores network, or onshore, and we can get baselines to where the ship is. But all of it's really tied to the satellite system and all pulls together to try and provide that access, that geodetic control to determine where that ship is, so that when it's doing either the sonar scan or it's dropping an XPT over the side or it's collecting whatever piece of information, or if it's in the air or any place. If you're collecting all this geospatial geographic information, then you need to have it fixed with some type of a reference system. That's the geodetic control. That's where we pull it in and say, here's where your geographic coordinates are, if you will, with respect to this system that we've defined.
Exactly.
And that's where your geospatial component comes in as a tie-in to make sure that it all is tied into the same system so that you can stack them all and get the most information out of it.
Or at least if it's tied into a system, it also is tied in a consistent way, kind of a thing. It's translating what it needs to. That's and this is for everyone else too. Anybody that takes a course from me or hears me talk or whatever, one of my favorite questions is, how do you know where you are on this earth right now? And they say, well, the satellites and the GPS in my phone. How do the satellites know where they are? And I was like, because they're not sending signals to each other, that albeit they do communicate sometimes, for figuring out where each other are relative to one another to make sure they don't hit each other. They're drawing a pyramid down to you, and they're drawing a pyramid out to the stars and things that aren't moving relative to us, because that's the only way.
Celestial reference system.
Exactly. Yep. It's the only way to base this, and it's fascinating to watch their brains kind of go because they didn't think about it that way before. So.
Well, and that's where it all kind of comes together. You get the celestial spatial reference system.
Yep.
The IAU helps with making the tie to the ITRS, the International Terrestrial Reference System, which is how we do things on the Earth.
Yep.
And you need to be able to pull all those together, because you're right. In an absolute sense, the Earth's deforming. You need something on the outside to look at that's, albeit moving, but very slowly.
Exactly.
And that is essentially, for our purposes, over our lifetimes, is fixed and not moving. So that's fine, and that's it.
We know it's in full motion. From a human perspective, we'll never even see it.
Not so much.
Exactly.
be
So
alive a long time if you know that.
exactly. Well, so in your opinion, like what is the geomatic slash well, geospatial, geomatic, or geodetic culture like currently? Is it I guess this is more from a diversity standpoint, right? Is there a lot of just white guys like us, or is there a diversity, or is the field becoming more diverse?
Well, up until maybe a few years ago, I would have said it was not diverse because, unfortunately, it was a bunch of old white guys.
Exactly.
To be quite honestly,
Old,
because
but
nobody qualified to, but that has more to do with the fact that nobody was coming in after me. I mentioned it before that Drew and I were like some of the last that came out, not the last, but there were certainly far fewer coming in after us.
Right.
The diversity sort of gets better because, quite honestly, the people that came in after us that we've hired are naturalized U.S. citizens. So they're not white people, to use that phrase.
Sure,
They're, other or other ethnic nationalities, but they weren't born here. They came to the U.S. and they naturalized. They became U.S. citizens, which is great. Don't get me wrong. I mean, that's an important thing too, to bring in people that can really contribute and all that. But we aren't generating interest from people within the United States in this field.
right.
It's maybe starting to change, but the bottom line is a lot of the programs shut down. I mentioned it a little bit. The Ohio State University program, the Geodetic Science and Surveying Department, folded. It was divvied up and sent to become like divisions within the civil engineering. Other programs have shut down throughout the country. And, others have kind of stood up in their place, but they just aren't there. And part of that is, and it comes back to what I commented on at the outset, was that when I went in, I looked around and said, I must be doing something wrong because I'm the only one paying.
Yep.
Well, that was because NGS, what was then NEMA and now is NGA,
Yep.
the U.S. Air Force, all were contributing their people. They were paying their people to go back and get advanced training, which is to say that you took the courses, and if you happen to stick around and get a master's degree out of it, that was your business.
Yep.
They didn't pay you to get a master's; they paid you to get advanced training. And if you got the degree, good for you. There's nothing wrong with that. But the point being, though, is that the people that came back to them had these advanced skills.
Yep.
That folded. And part of the reason that the department went away is because the funding dried up. And funding dried up because a lot of it was like, well, we've done all this. We don't need to worry about it anymore.
Yep.
Berlin Wall fell. We don't have to worry about this space race or these concerns anymore. Well, I'm not sure if you saw the white paper from
I did.
Beavis.
There's questions coming up on that you don't have. So
that's fine.
Yeah.
Mike Beavis, mostly from the NGA perspective, because he talked about national security and other issues, really did focus on concerns about the lack of geodesy training programs in the United States. We got all these things I kind of talked to. I mean, all these things we want to do, precision navigation and, and having the accuracy and tying in the critical infrastructure and knowing where the pipelines are and being able to go out and say, here's the pipeline, put a GPS receiver on it. Okay, now bury it and know that you can relocate it if you need to go and replace that section of piping because you GPSed it before you put it in the ground. You know where it was before you put the dirt on it.
Yep.
And you know how the pipeline is, and you know how the water or the fluid or whatever's in that pipeline is going to flow. And you can take advantage of fluid dynamics to reduce the number of pumping stations, or you can figure out floodplains or any number of potential applications. All these wonderful things people say they want to do. NASA's got a whole 2-decadal papers now that they put out, sponsored by the National Academy of Sciences, that talk to all these specific issues where having precision and accurate GNSS information can provide you all these wonderful things that you could be doing. Yep. But we don't have anybody who can do them. There are no programs. And Mike Beavis's comments, he was lamenting the fact that there is no, he and others have come to us and said, can't you pay for some of this stuff? And we're like, no. We are stovepiped. We are an operational agency. Yep. We receive our money to perform. You receive X dollars to do Y tasks.
Yep.
And that doesn't include doing research and development or funding or granting money to other agencies to do stuff.
That was not NASA and other agencies like that back in the day. Yep.
NASA, and we had enough money, and we were still doing NEV 88 and NAD 83 and all this different projects. So we were able to afford to pull out some of that money and send people for advanced training. But once those projects finished, they said, okay, that's it. And we haven't sent anybody really since then. I mean, I think about it. Drew came in 95. I came in 99. Granted, I took the longer route, but really we were the end of it. And after 91, about the time of the Berlin Wall and all of that,
Yep.
that's when a lot of the funding started to disappear. And 1991 was also when NAVD 88 was rolled out. So no longer were they sending anybody through OSU. I'm just picking Ohio State University only because that was the program I was involved with.
Yep.
But there were all these other programs too, and a lot of that's diminished. Some of it's been put in place. Center for Space Research down there at Austin in University of Texas. They were reinvigorated. There was a lot of Grace Follow, and a lot of satellite geodesy. And that's good because the satellite geodesy really does bring it together and provide that global look. But we live on the surface, not in space.
Yeah, not yet.
Wait, not yet. True. Yeah. Well, most of us live down here. Let's put it that way. And the signals attenuate as you go into space. So if you really want high resolution signal to understand where water's going to flow, you need observations at the surface of the Earth, period. Exactly. And so we need to have people that understand physical geodesy and understand all the leveling and understand the GNSS and understand how to pull it together. I mean, one of the limitations, everybody's like, oh, we love GS84. Well, it's great, but that's GPS only.
Exactly.
Okay. And some of the other systems are maybe somewhat suspect, or I don't know how reliable or reliant we can be on them. But Galileo is certainly one, and there are other systems that we can rely on where having redundant information might be useful. It doesn't say, I mean, sometimes GPS only is the best solution.
Yeah.
But, if you have other systems, you can compare, you can do the combined solutions, you can do them separate, and you can find out what the optimal result is. It's nice to have extra information.
Exactly.
But if you're only using WGS84, then you only can choose one system. That's why we're relying on GNSS, meaning all of the, like the major four and all the other signals, again, with the jaundiced eye, towards the signals we're receiving, making sure that we have confidence in what we're getting.
Yep.
I mean, we want to make sure we're providing the most accurate and precise coordinates. Yep. So we have to always be conscious of the signals we're receiving and what they might mean. But all that aside, again, all these wonderful things we want to do, but who's doing it? There are no programs, there are no advanced training. You ask about, diversity and all of that. I say right now, we'll take anybody. Yes, okay, it'd be nice to have more diversity in what's coming in. I would say that we are starting to see a little more diversity. I know a number of the division chiefs that have come in and taken over and positions of responsibility are female. Mm-hmm. That would be a Caucasian female, but nonetheless female. And we're starting to make progress and bring others up and through the ranks.
Yep.
But the problem is still, there's just not enough opportunities to send people out for the training. We really have to scrimp and save and basically not hire somebody to send somebody out for advanced training now. We have to take the money that we would normally take to hire somebody in, save the money, send them to the training, take it out of hide, get them trained, bring them back, and then we can hire somebody.
Exactly. Well, but it's a time game, right? It's a consistent time game. And that's an issue too, because it's like, well, where does this go? How long is everyone going to be in? It's a whole other decision-making that's outside the science. And that's the scary part. Because
what's needed is a more robust program. We need somebody like NASA. NASA is the proper path for it, if you will, because NASA has deep contacts with the research and the universities. NASA, if funded, could pay for all of these programs. They could stand up a lot of these research elements, these things that people want to do in terms of smart highways, autonomous vehicles, precision navigation, and accuracy, and all these types of things would be best sponsored through NASA to the universities to get all this research and development going on to meet mission needs, not necessarily just for the NGS, but the Department of Transportation. They have all these great ideas of things they want to do, and they're trying to go to industry to do it, but industry doesn't. They're having the same problem. Who do they hire? They don't have any geodesists to go hire either. So there's not enough people to get trained through the academic side to go out into government, to go out into industry, to go out and to do this type of work so that we can flesh out the number of bodies that we have that know enough about geodesy to actually be able to make all these programs be fulfilled. So it's a starved program right now, I think, is the issue. And then I would definitely welcome diversity. And certainly, I mean, I'm like, I would be glad to hire white people. I'd be glad to hire anybody, and not just white people.
Exactly.
It's not like, oh, no, and it's not just, right now we lack bodies. So anybody who can come. is welcome. If you know what you're doing, we can bring you in and we can get you training, and you have a passion for it, then we're certainly welcoming you. The problem is where do they go? I mean, there are no programs for them to go to, even if there was an interest, even if they knew what Geodesy was, which is some of the problem too. I don't know how many times people say, "Oh, you're with the National Geographic Society." No.
I didn't know you
"Oh,
worked
you're
with
with
the National Geographic
USGS."
Society. No.
No.
Well, and I think that's a big thing, especially for the viewers. And one thing I wanted to comment really to this white paper that everyone hears us alluding to here, there, and everywhere else.
Right.
It will be included with the link, and we'll have a copy on YouTube for you folks. But it's America's loss of capacity and international competitiveness in geodesy, the economic and military implications, and some modes of corrective action. And much of what Dan is talking about here today is very much on this area where we're running into an issue where we don't have the people that we need to fill the positions to help define the standards for us. And if left to the open market, and this is one area where I'll disagree with you on business, even though I'm a business owner, we're financially driven, right? If the money's not there, we're not going to pursue it. And if the money isn't in our favor, we're not pursuing it. We're not government agencies doing this for free. We have people to pay, we have things to cover, we have bills to service because we're working with other businesses. So the more we try to push this off onto other industries, the less effective it becomes, because no one's going to, well, if you don't do your dishes at home and no one does the dishes at home, everyone just waits for that one person to do the dishes, right? Exactly.
Yeah, exactly.
And now it's just a moment of who can deal with it until somebody breaks. So
well, and what that gets to is a term what we use a lot of time, which is what is inherently governmental here.
Exactly.
It is inherently governmental to do tasks that are for the common weal, for the benefit of all society, that there is no business case for. Exactly. There's no business case for you to go out and do this work because you're not going to make money at it.
Yep.
We don't make money. I mean, people have an issue like, oh, the government's not, it should be run like a business. Some aspects of it.
Yep.
But many other aspects should not be run because we aren't doing things that are going to necessarily be something that industry could do because there's no profit in it. But when we do it, there is an inherent benefit.
Exactly.
And we referred to it before, is by defining a common reference system. If all the cars in the country now are autonomous and they're going down the same roads on the same reference system, then the navigation becomes safer.
Right.
And as opposed to everybody having their own, and it's the wild, wild west, and somebody has VHS and somebody has beta. For those who are really old here.
Exactly. Yeah. Well, but to your point too about the government should not be run like a business. As I always tell people, being a former bureaucrat and working for a state government or a few state governments, the biggest thing I always told them, sure, efficiency is what you're looking for that word. The difference being is that a government can't fail, because when a government fails, you lose everything. When a business fails, a new business steps in. Typically, you don't see a new government. France tried it. It took them a few years. They were pretty bloody, but it is, back during the French Revolution. But that's the thing. And that's why it is imperative, in my opinion, especially for like government agencies like yours, that they get the funding that they need to do the things and set the standards for people like me to go out and conduct the work that people need for their cars, for whatever, to better range in data to make it successful. We're not, like you said, we're not making money when we go out and do the whole country, albeit we can sell those data sets and it could make us money there. But if we don't standardize it and make it into a thing that's accepted, and you guys go out and make a completely different model and we're a different model, well, who's who? And it gets into a whole other conversation on that front.
And that's where leadership is supposed to come in. We're supposed to provide the leadership as the government agency responsible for it. Again, it's hard because we don't have a mandate that says the United States, all U.S. citizens have to adhere to this. No, they don't. It's not the case at all. I mean, it is other government agencies internal to the government. But if you have business in front of the government, like I said, we talked about it before, how it kind of percolates out. And it makes sense then for a consistency point of view that everybody aligned to the same system. And it makes a business sense too, then, because if you know that if you're aligned to the system, then it's going to work in Canada, going to work in Mexico, going to work in the Caribbean, going to work in Europe, going to work in Australia, going to work everywhere around the world. Yep. And you only have to have one reference system. You don't have to be constantly transforming it. That makes things simple. And things that are simpler are usually cheaper, and cheaper things are always good for business.